All right, guys. In today's class, we are going to concentrate on mole, mole calculation, and all the rest. So I want you guys to pay attention because I'm giving you a background of what the mole concept is all about, and this mole concept will lead us into stoichiometry. Okay, so let's go. In more concepts, what we are looking at are number of moles is mass over molar mass. Number of moles is mass over molar mass. So the mass of a substance is measured in gram, while the molar mass of a compound is measured in gram per mole. That is the first thing you will need to know. Mass over molar mass. So we call that one equation 1. We also have number of moles is concentration. Number of moles is concentration. This concentration must be measured in mole per dm cube. This concentration must be measured in mole per dm cube. Multiply by volume. This volume is in dm cube. Then you don't need to divide it by 1000. So this one, we call this one equation 2. So it means number of moles is concentration that is measured in mole per dm cube times volume. The volume is measured in dm cube. You don't need to divide by 1000. Whereas if you are given a volume and the volume is measured in cm cube, then you need to apply the second formula. That will be concentration times volume. If your volume is given in cm cube, then you need to divide it by 1000. The question is why? Why do you have to divide it by 1000? Because volume can be measured. Volume can be measured either in cm cube or can be measured in dm cube. And what is the relationship between cm cube and dm cube? 1000 cm cube is equal to 1 dm cube. That's the reason why we had to divide by 1000. That's the reason why we had to divide by 1000. So that's number 3 equation 1, 2, 3. Then we can start equating this. Why? Because mass over molar mass is number of moles. Concentration in mole per dm cube times volume in dm cube is number of moles. All these 1, 2, 3, they are all moles. So I can equate them. Very simple. I will say equation 1, that's mass over molar mass. Mass over molar mass, that's equation 1, can give us equate it with equation 2. Concentration times volume, provided your volume is in dm cube. That will be equation 4. So for equation 4, mass over molar mass equal to concentration times volume in dm cube, that's equation 4. Okay, so what I did was I just equated equation 1 and 2. That's what I did. Okay, so let's go to equation number 5. So in equation number 5, what I'm going to do is I'm going to say mass over molar mass, mR represents molar mass, equal to, then I'm equating with this one, concentration times volume. If my volume is in cm cube, All I need to do is divide it by 1000. That is equation 5. So you have equation 1, we have equation 2, we have equation 3, and we have equation 5. All right, very simple. Now, 1, 2, 3, 4, 5, we are going to use it now. The very first thing is, as a chemistry student, you need to know how to write a correct chemical formula as well as a balanced chemical equation. But not to worry. Why? Because those topics will be taken separately. I just want to show you a few things. Now, what are the few things I want to show you? Now, I want everybody to pay attention. Number one, I'll give you some questions and we can now play with it. What is that? I can say, how do we calculate? That's the first thing. Finding molecular mass. How do we get molecular mass? As simple as this thing is, I just want us to go over it. And some people say, no, I already knew this one. No problem. Let's just go over it. Did I call it molar mass or call it relative molecular mass? Did I call it molar mass or call it relative molecular mass? So did I call it molar mass or relative molecular mass? Now, how do we look for it? All you need to do is to sum up all the individual atomic masses given to you in a question. So let's look at it this way. Number one, if I say find I'm going to have MR, subscript R for molar mass. So find the molar mass of carbon dioxide. Very simple. You'll be given in the question that carbon is 12 and oxygen is 16. You'll be given in the question. So don't worry, you'll be given this one. Always, 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 you'll be given. So what do? Find the relative molecular mass of carbon dioxide. Simple. So we look at this solution. We'll see solution. So what is the solution to this one? Very simple. You say MR, that's relative molecular mass of carbon dioxide, is a sum of all the relative atomic masses. So that's going to give us, what is carbon? Carbon is 12. Plus, what is oxygen? Oxygen is 16. But remember that you are given 2 of oxygen. So multiply that by 2. If you do this math, it's going to give you 44. And then put the unit, 44 gram per mole. That's how to find the molar mass. Very simple. Molar mass is found or determined by adding all the individual atomic masses in a compound. Fine. Let's go to number 2. Question number 2. I just want to do 2 more then before we move on. Question number 2. If I ask you, find the relative molecular mass of sodium trioxocarbonate 4. Find the relative atomic mass or molecular mass rather of sodium trioxocarbonate 4. Then you are going to have sodium will be given as 23. Okay. Carbon will be given as 12. No problem. Then oxygen will be given as 16. Very simple. All you need to do is to sum up all these relative atomic masses. So the relative atomic mass or masses, just sum them up. So what that's going to give us, the molar mass of sodium trioxocarbonate 4. I'm looking at solution now. The molar mass of sodium, the molar mass of sodium trioxocarbonate 4. What is it? Sodium atomicity. So what's that? I just introduced a word and I want us to look at that. What's atomicity? Is the number of atoms present in a molecule. the number of atoms present in a molecule is known as atomicity. So very simple. What is the molar mass of this compound? Very simple. You just do a thing like this. Molar mass is going to give us sodium is 23 multiplied by 2, okay, plus carbon. Carbon is 12. Then you have 16 times 3. So let's do the math. This one is 46 plus 12. Well, 12 plus 16 times 3. What is that giving you? 16 times 3 is that's 18. 18 plus that's 18, almost 48. Now, if you add up everything, that should give you 106 gram per mole. So that's the molar mass of the compound. The molar mass of the compound is 106. That's the molar mass of the compound. All right, so now, why is it important for me to look at the molar mass? Because when you are solving your number of moles, you are going to look at molar mass. Molar mass of the compound is very important. And one more thing I want you to note is that apart from looking at the molar mass of the compound, by the time you start solving questions in stoichiometry, you are going to know how to write a balanced chemical equation as well as writing the chemical formulas. So those topics will be taught separately. So that's the way we are going to do it. But let me quickly finish all of the other formulas. I have 5 formulas already I've given you. So let me quickly finish, because in the next class, we are going to be using them. So I want to quickly finish it in this class so that you can be familiar with them. So I want you guys to be familiar with them. That's why I'm taking them now. So I have equation 1, I have equation 2, I have equation 3, I have equation 4, then I have equation 5. Now I'm going to equation number 6. So what is equation number 6? Remember that 1 mole of a gas, remember that 1 mole of a gas at STP, 1 mole of a gas at STP. What is STP? STP is standard temperature and pressure. Standard temperature and pressure. At STP, 1 mole of a gas is equal to 22.4 dm cube, 22.4 dm cube, or 22400 cm cube. 1 mole of a gas at STP is equal to 22.4 dm cube or 22400 cm cube. Okay, anytime you are given a question and you have to calculate the volume or calculate anything that has to do with a gas at STP, you must put this one in your mind. So it's something that you must know. You must put it in your mind. So how do we use it? Now, number of moles is equal to volume. If your volume is in dm cube, that means the volume given in the question, if it's in dm cube, all you need to do is to use this formula and say divide it by 22.4 dm cube. So number of moles is equal to volume in dm cube divided by 22.4 dm cube. So this one is going to be equation number 6. Equation number 6. Then, okay, so the next equation, what if my volume is given in cm cube? I told you that the volume of a gas, or volume generally, is that is given in dm cube or is given in cm cube. So let's go. What if my volume is given in cm cube? I'm going to use volume in cm cube will be divided by 22400 cm cube. I call that one equation 7. So for equation 7, number of moles is volume. Volume is in cm cube. then divide it by 22400. Now remember, this equation is different from the one that we had concentration. Why? The one for concentration is talking about solution. Why the one for 22400 cm cube or 22.4 dm cube is talking about a gas, and that gas must be at STP. So when a gas occupies a volume at STP, quickly your mind should visit this 22.4 dm cube or 22.4 dm 22400 cm cube rather, or 22.4 dm cube. Equation 6 and 7, I can equate it with the previous equation 1. Very simple. How do we do that? So I'm going to take this off the board. Why? I'm going to equate equation 1 and equation 6 and 7. I will equate equation 1 and equation 6 and 7. So let's go. Equation 1, remember, equation 1 says number of moles is equal to mass over molar mass. That's equation 1. And then I am going to have, please pay attention, then mass, in this case, over molar mass equal to volume. If my volume is in dm cube for a gas, divided by 22.4 dm cube. I call that one equation 8. I call that one equation number 8. So equation number 8 is mass over molar mass equal to volume in dm cube divided by 22.4 dm cube. All right, equation number 9 is going to be mass over molar mass equal to volume. The volume is in cm cube divided by 22400 cm cube. That's that. And that is equation 9. So equation 9 is accounting for when the volume is in cm cube. Equation 8 is referring to when the volume is in dm cube. All right, remember, when you are using this formula, remember you are using it when you are asked to calculate anything that has to do with a gas at STP. A gas at STP. All right, so now let's go to the other equation. So we have equation 1 to 9. So we are not done. Like I said, I want us to finish all the equation now so that we can take questions later. All right, so now we have 1, 2, 3, 4, 5 up to 9 equations. This time around, we are going to look at the next equation. Now, the next equation is talking about number of particles. The next equation is talking about number of particles. The next equation is talking about number of particles. Remember that if you're talking about particles, you are referring to 3 things basically. You are referring to 1, atom, 2, molecule, and 3, you are referring to ion. So particles refer to atom, molecule, and ions. How do I get to know this one? Remember, there are 2 theories of matter. Remember, there are 2 theories of matter. The first one is the particulate theory of matter, which states that matter is made up of particles. This is the particles in matter. Or number 2, you know that you are looking at kinetic theory of matter. Kinetic theory of matter states that all the particles in matter are usually in random motion or in a state of motion. So that is kinetic. But those kinetic state of matter, we study them basically in gases. So, but that's not what we are doing now. We are just looking at the concept particles of matter. So you have atom, molecules, and ion. Now, according to Avogadro, 1 mole of a substance, according to Avogadro, 1 mole of a substance is equal to 6.02 times 10 raised to the power of 23. According to Avogadro, 1 mole of a substance is equal to 6.02 times 10 raised to the power of 23. Now, what does that mean? It means 1 mole of a substance. What substance? It could be a compound, it could be a molecule, it could be an atom, it could be an ion. 1 mole. Remember that mole is mass over molar mass. We're going to do that later. So these are constants. Avogadro said this is Avogadro's constant. This 6.02 times 10 to the power 23 is Avogadro's constant. So how do we relate this one? Very simple. According to this one, number of moles will be number of particles over 6.02 times 10 raised to the power 23. Remember that Avogadro's constant is 6.02 times 10 raised to the power of 23. I call that one equation 10. Equation 10 says that number of moles is equal to number of particles over 6.02 times 10 to the power of 23. Okay, so what do I do from here? I can also equate equation 10 with the previous equation 1. And very simple. So that's going to be mass of a substance over molar mass equals to number of particles. Now, recall that I said particles refer to what? Atom, molecule, and ions. That will give us over 6.02 times 10 to the power 23. I call that one equation 11. So I have equation 1, equation 2, all through to equation 11. Just a few more to go, and then we can now get to the other side of the class. So, all right, so in equation 12, I'm kind of leaving this, I'm just relating it to gases now. Now, I want you to pay attention very well. And what is the thing I want you to do? There's a particular law in gas laws, and the law is law of Dalton or of partial pressure. Dalton's law of partial pressure. Now, that law talks about mole in a way. How? So you can relate more concepts to that law. How? According to Dalton said that if you put gases in a container, you have gas A, B, and C, that each of these gases, they will start colliding with each other. That's what I told you about the particulate nature of matter. So about the kinetic theory of matter. Gases, the particles will start colliding with each other. Not only that, they will collide with the walls of their container. When they are doing that, they will generate a pressure, and that pressure is called gas pressure. So when you put them together and they do not react chemically together, you need to take note of that. They do not react chemically together. So you are going to have the total pressure exerted by ABC will be equal to the sum will be equal to the sum. What is that? B, and you have C. So you have total pressure exerted by a mixture of gases which do not react chemically together is equal to the sum of their individual partial pressure is equal to the sum of their individual partial pressure. Okay, so what does that mean? So total pressure of ABC now is equal to partial pressure of A, partial pressure of B, partial pressure of C. So sum them together. So JAM, according to JAM's lab, that's okay, fine, no problem. Can you do partial pressure for us? That's very simple. So what is partial pressure? What is partial pressure? Partial pressure can be simply put as the pressure exerted by a gas when it's placed alone in its container. The pressure a gas exerts when the gas is alone, that's partial pressure. No, mathematically, we can define partial pressure. Mathematically, we can define partial pressure of any gas. Mathematically, we can define partial pressure of any gas. How do you do that? You say partial pressure of any gas, let me say it's gas A, is mathematically defined as the product of total pressure times mole fraction. Pay attention very well. So PA here represents partial pressure. PA represents partial pressure of the gas. Then PT represents the total pressure of the gas in the mixture, while NA is the mole fraction. This is what's led us to this concept, the mole fraction of the gas. So since it's gas A I'm dealing with, that's the mole fraction of gas A. Very simple. How do we do this? Okay, so now I want to remove this mole fraction and define it. I want to remove this mole fraction and define it. So I'm going to take this off the board. So quickly, I'll get this off the board. Now, what do we do with this information? Whenever you are asked to find mole fraction of a gas, what does it mean? That means you'll be given plenty moles of a gas, of gases mixture. Then you can find one of them. A fraction is an expression that has a numerator and a denominator. No problem. So which means that what is a mole fraction, or what is mole fraction? Mole fraction of any gas, I'll have it as gas A. Mole fraction of any gas can be mathematically expressed as the ratio of the number of moles to the total number of moles of all the gases in the mixture. So now this one I can call it equation 12. Now you might be thinking, now Doki, all these things you are doing, how do we use them? No problem. The very essence of this first class is to get yourself acquainted and familiarize yourself with the formulas. Don't worry, I am going to use each of these formulas for you. You don't have a problem. So from formula 1 to 12, we will take questions, ample questions, many questions on them. For those who have ears, let them hear. Thank you.